Welcome back, and we're going to continue on and look at another way to solve quadratic equations. And the next tactic is likely something that we've done and seen before, but we're just going to give it a name, and it is using a square root. Okay, the book that we use for this course calls it a square root property. I just think of it as you do a square root, right? And so this, though, is only valid. We can only do this if it's in a very specific format. And the format would look something like we have x, and I do use capital X here on purpose. So we have something squared on the left side of the equation, or right side, doesn't matter. We have something squared on one side of the equation, and then we have a number on the other side. And then we need to get at the x on the left-hand side of the thing that's squared, so you have to introduce a square root, right? So square root both sides, right? And then the thing that I always remember to point out here is that in addition to introducing a square root on both sides, you need to include a plus and minus on one of them, okay? Because you can, for example, if we have 5 squared, that's 25, right? But also negative 5 squared is 25. So we don't know whether the original thing, if we're undoing that, was positive or negative. So that's why we need a plus and a minus. Okay, and so then you get 2 solutions, and then you might have to go further. All right, so let's see this in a couple examples. All right, so first example, right, I have 25 minus x squared. That's a quadratic equation, right? But this this method requires us to isolate, the variable of interest on one side. So I'm going to move the x squared over. Okay, and so I get 25 is equal to x squared. And now I'm going to do the introduction of the square root, and I'm also going to include the plus and minus on one side. Generally, you include it on this side opposite of the variable. And so square root of 25 I know is 5, so I have plus or minus 5 is equal to x. And it's perfectly fine to express the answer like that, or if you want to do x is equal to 5, or x is equal to negative 5, write them both out, that is acceptable as well. Okay. So again, a strategy you maybe have used before, we're just giving it a name and formalizing the process, okay? So here in this next one, I want to isolate the quantity that is being squared if possible. So isolate the c squared, so divide by 2, and I get c squared is equal to 49. Oh, I know that's a nice square root. So I'm going to do square root, include a plus and a minus, so c is equal to plus and minus 7. Okay, aren't these nice and easy to solve? Well, and then we get to the next one. Okay, so again, we want to isolate the x squared. Okay, I want to just have that. So let's see, I have to subtract 4 first. Okay, so 1/2 x squared is equal to 20. Okay, is this going to be nice? I don't know. Multiply by 2 or divide by 1/2, depending on your personal preference. So I have x squared is equal to 40. You're like, oh crap, that is not easy. That's okay, we can work with tough things. So introduce a square root and introduce a plus and a minus. So x is equal to plus or minus square root of 40. And we have worked with radicals, so we can simplify this. 40, I'm thinking about my numbers, so this is 4 times 10, right? And 4 is a nice square root, so I could actually write this as plus and minus square root of 4 times square root of 10, which gives me plus and minus 2 square root of 10. And I want to try and break down radicals as much as I can, okay? It's a good practice to do so. And you get to show off your math skills, flex your math muscles, okay? There you go. Okay. Next one, okay, that one looks about as complicated as the previous one, and I think it is. So again, we want to get to A, but to do A, to get to A, there's a 3 in there, there's a square, and there's a 3. So what I need to do is isolate the thing that's being squared first. So I need to isolate that, undo the 3. Okay, so divide both sides by 3. I get a minus 3, quantity squared, is equal to, and this ends up being 18. Okay, this is uncomfortable, but we can work with uncomfortable things. Square root to undo the square and include a plus and a minus. So I have a minus 3 is equal to plus and minus, and then square root of 18. Okay, now technically all I need to do is move the 3 over, and I'd be done, but I'm going to say that's not enough, because I want to try and simplify the square root of 18. Okay, 18 I know is 2 times 9, so I can do this as a is equal to 3 plus and minus, or plus or minus I should really be saying, square root of 9 times square root of 2. And so I get a is equal to 3 plus and minus 3 square root 2. Okay, and this form of the answer is fine, but again, if you want to break it into two things and say this is a is equal to 3 plus 3 square root of 2, or a is equal to 3 minus 3 square root of 2, that is fine as well. With these things, do not give me decimal approximations. You will get unhappy comments back. Generally in mathematics, we always want to use an exact answer, which involves square roots and fractions, unless otherwise indicated. Okay, so read the directions. Here, I guess it is non-specific. I will be specific in class and on homework. All right, but you've been warned to leave everything in exact form. Okay, next up. Okay, this ends up being a perfect square factor pattern of 4n plus 5 quantity squared. So you might have to use some accessory skills as you do the square root property, right? So just be aware of that. And then introduce square root. Square root. We get 4n plus 5 is equal to plus or minus square root of 2, or plus or minus 2. Sorry, square root of 4 is 2. And then we have this one. This is a little bit more complicated. You could subtract 5 divided by 4. This one, it might be easiest to break it into two equations because you have two things going on here. So break it into positive 2, or 4n plus 5 is equal to negative 2. Solve each one. 4n is equal to subtract 5, you get negative 3. Subtract 5, you get negative 7. And then divide by 4, negative 3/4, or n is equal to negative 7/4. Okay, there we go. Okay, so point of these exercises are, right, once you get the square isolated, square root, include a plus and minus, and follow through with the remaining algebra. And that's it for this technique.